Hi guys, this is a video solution for CAMONTEST for 11th class that happened last Sunday. Let's get started. So the first problem says a car travels along a straight line for first half time with speed 40, for the second half with speed 50. The mean speed of the car is, so situation is something like this. This is A, this is B. For half the time he travels with 40 and for half the time he travels with 50. So we have to find average speed, which is equal to total distance traveled. Let's say this distance was D. So D divided by time taken, so that is equal to T. Now how can I write the distance traveled? It would be D1 plus D2. So D1 is 40 speed for T by 2 time and D2 is 50 speed for T by 2 time, total time T, and this comes out to be 40 plus 50 over 2, that is 45 km per hour. That is option number B. Question number 2 says a car travels the first third of its distance, now it's the distance, with a speed of 10 km, second with 20 and third with 60. Average speed of the car. So now the situation is like this: A, B, C and D. So this is D by 3, this is D by 3, this is D by 3. This distance is traveled with 10 km per hour, this is 20 km per hour, and this is 60 km per hour. Now we have to find again the same thing, average speed, which is equals to distance over time taken. Now the distance is D only, but the time taken is T1 plus T2 plus T3. So time taken for this guy will be D by 3 is the distance over 10 plus D by 3 is the distance over 20 speed plus D by 3 is the distance over 60. And D gets cancelled and we have 1 over 30 plus 1 over 60 plus 1 over 180. So 180 is the LCM, goes to the top. Here we'll have 6, here we'll have 3, here we'll have 1. So this comes out to be 180 over 10. That is 18 km per hour. Question number 3 says a car travels from A to B with a speed of 20 km per hour and returns with a speed of 30 km per hour. Average speed. Okay, A, B, he goes there with speed of 20 km per hour, comes back with 30 km per hour, and you have to find again average speed, which is equal to total distance traveled, distance over time. Now the total distance traveled over this period is D in going and D in coming back, so twice of D. Time taken is T1 plus T2, so T1 plus T2. Now what's T1? Again, like the last question, time equals distance over speed, so distance is D, speed is 20. Similarly T2 will be D over 30. If you take the LCM, then it comes out to be 60, and this will be 3D, this will be 2D, and this will be 2D into 60 over 5D. D gets cancelled, 5 cancels 60 by 12, and answer turns out to be 24 km per hour. Question number 4 says a car moving with a speed of 40 km per hour can be stopped by applying brakes after at least 2 meters. So this car is traveling with 40 and he will be stopped, that is final velocity will be 0 and distance traveled would be 2 meters. If the same car is moving with 80, what's the minimum stopping distance? Same car, that means acceleration, that is negative acceleration, would be same in both the cases. So what would be acceleration in this case? We have to find out. So we are given initial velocity as 40, final velocity as 0, and distance equals 2. So which equation to apply? V square equals u square plus 2s. So 0 square equals 40 square plus 2 into acceleration into 2. So acceleration is 1600 over 4, that is equals to minus of 400. And the same acceleration is applied over here, and in this case u equals 80. Final velocity is again 0, but you have to find the displacement s1. So let's apply the same equation again. 0 square equals u square, that is 80 square, plus 2 into acceleration, that is minus of 400 into s1, and s1 equals minus of 80 into 80 over minus of 2 into 400. 0, 0 cancelled, 4 into 2 and 2 cancelled, minus minus cancelled, and S1 is simply 8 meters. Question number 5 says, a car moving along a straight highway with a speed of 126 km per hour is brought to a stop within a distance of 200 meters. The retardation of the car is, and how long does it take for the car to stop? So we have to find time and retardation. So the situation is like this. A car is moving from point A to point B. Initially its speed was 126 km per hour. Now its final speed is 0 and distance traveled is 200. So it's again like the last question, v square equals u square plus 2as. So let's apply that formula, but before applying we have to convert this 126 km per hour into meter per second, because everything is in meters and seconds. So this goes to 2 and this is 14 and this is 7. So this comes out to be 35 meters per second. Now let's apply the formula. 0a square equals 35 square plus 2 into 200 into a. So a is 35 square but negative of it by 400. So this is 35 into 35 over 400, 7 and 80 and 16 and 7 again, 49 over 16. So 16 into 3, 48, 3.06 looks right. For safety, let's calculate the time also. So for that we have to apply v equals u plus 80, final velocity is 0, initial velocity 35, and acceleration we are getting is minus 49 by 16 into t. So t is nothing but 35 into 16 over 49, 7 into 5, 7 into 7, 80 over 7. That will turn out to be around 11.4. Question number 6 is, a body moving with uniform acceleration describes 12 meter in third second of its motion and 20 meter in fifth second of its motion. The distance covered in 10th second is. Okay, so our body is here. First, second, third, fourth, fifth, and so on. So in the third second, that means it's talking about this. So you have to find velocity here. What would be velocity here? It will be u plus a into t, but t would be this t, right? So that t, now this becomes u for here to here motion. So you can find the distance traveled equals ut plus half at square, where u will be this and time will be 1 second, and acceleration is the whatever the constant acceleration it was moving with. So let's try to form some equations. So first, it travels 12 meters in third second. That is, third second means velocity here would be u plus 2 into a after 2 seconds. So 12 equals u plus 2a into time taken is 1 second plus half into a into 1, which is 12 equals u plus 2a plus a over 2. So 12 equals u plus 5a over 2. Let's apply the same thing for the other case. So it moves 20 meters in the fifth second, that is after 4 seconds, its velocity would be u plus 4a, that would become its initial velocity. So 20 equals u plus 4a into t, that is again 1 second for the fifth second, plus same half into a into t square, that is 1. So this comes out to be 20 equals u plus 4a plus again a by 2. So 20 equals u plus 9a over 2. So you can find both u and a from these two equations. So let's do that. Equation number 1 minus equation number 2, that will give you minus 8 equals u gets cancelled, 5a minus 2 minus 9a minus 2, that is minus 4a by 2, that is minus 2a. So a comes out to be 4 meter per second square. Now putting this in one of the equation, 20 equals u plus 9 into 4 by 2, so 18, so u equals 2 meter per second. Now the question simply asks the distance covered in 10th second. So 10th second after 9 second velocity would be u plus 9a, and distance covered in 10th second would be u plus 9a into time is 1 second plus half into a into again 1. So let's put the values over here. So 2 plus 9 into 4 plus 4 over 2. So this will give me 40 meters. Alright, question number 7 says, a particle when thrown moves such that it passes the same height at 2 and 10 seconds. The height is. So the situation is like this. A ball is thrown with some initial velocity u. It goes to the top, comes back. It's here at 2 seconds as well as at 10 seconds. And you have to find this height h. So h can be written in two ways. First, at t equals to 2, h can be written as u into t, which is 2, minus half into g t squared, which is 2 squared. And from t equals to 10, it can be written as h equals to u into 10 now, minus half into g into 10 squared. So we have two equations and two variables, h and u. And we need to find h, so let's eliminate u. For that, here is 10u, here is 2u, you have to multiply equation 1 into 5 minus equation number 2. So this becomes 5h minus h equals to 10u cancelled, minus half into g into 4 into 5 plus 50g. So this comes out to be minus 10g plus 50g, so 40g. So 5h equals 40g and h comes out to be 10g. So D is the correct option. Question number 8 says, a packet is dropped from a balloon which is going upwards with a velocity of 20 meters per second. The velocity of the packet after 2 seconds would be. So there's a balloon which was going up with 12 meters per second, and from here you dropped a packet. Now the packet will also gain the velocity of the balloon, 12 meters per second. So packet will go something like this. And you have to find velocity of the packet after 2 seconds. So that's quite simple. V equals u plus 80. Initial velocity is plus 12. Acceleration is minus g into time is 2 seconds. So if you take g as 9.8, it will get you 12 minus 19.6. That is nothing but minus 7.6 meters per second. So it has already turned after 2 seconds and is moving with a speed of 7.6 meters per second. Question number 9 gives you a velocity time graph. This velocity is in meter per second and time is in seconds, and you have to find the distance traveled by the body in 5 seconds. So you have to find the distance, so you have to add up all the areas. You know that displacement is the area under velocity time graph, but in displacement you take this area as negative, but you have to find distance. You'll take this area also as positive and you'll add to all of the areas. So you basically have to find the area enclosed under velocity time graph. So this is area of a trapezium, so half into 2 into 20 plus 40, which is 60. And area of the square is 20 into 1, that is 20. Area of this triangle is half into 20 into 1, that is 10. Area of again this triangle is half into 20 into 1, that is 10. Total area comes out to be 100. So distance traveled is 100 meters, but if you talk about displacement, that would be only 80 meters. Question number 10 says, velocity time graph is given. Find the displacement in 3 seconds and average velocity from 0 to 10 seconds. So displacement time graph is something like this: 4 meters per second from 0 to 2 seconds. Then velocity is 0 from 2 to 4, and 4 to 6 velocity is minus 2. So 6 velocity is minus 2. Then till 10 it's 0 again. Find the displacement traveled in first 3 seconds. So first 3 seconds, that is still here, displacement is the area under the curve, which is 4 into 2, that is equal to 8 meters. And average velocity from 0 to 10 seconds is total displacement. Now total displacement is that positive 8 minus 4. So 4 meters, and average velocity would be 4 over 10, that is 0.4. So option number D. Alright, so let's move on to question number 11. Question number 11 says, for a projectile, ratio of maximum height reached to the square of flight time is. So let's get down the formula. H equals v square sine square theta upon 2g, and t equals 2v sine theta upon g. So let's try to convert h's formula into t square. So h can be written as 2v sine theta by g whole squared. So this would give me 4, so I have to divide by 4. This would give me g squared, so I have to multiply g. Plus 1, 2 was already there, So h comes out to be t square g over 8, and ratio of h over t square is 10 over 8 equals 5 over 4. Question number 12 says a ball is thrown by one player, reaches another in 2 seconds. The maximum height attained by the ball above the point of projection is about. Again, so this is a relation between t and h. So you are given t, total time period is 2 seconds. So this ball is thrown from here to here, and t equals 2 seconds. You have to find h. So just now we got the formula that h over t square comes out to be g over 8. Hence h equals 10 over 8 into 2 into 2. That is 5 meters. Question number 13 says the greatest height to which a man can throw a ball is h. What is the greatest distance to which a ball can be thrown? Alright, so this is the height that a man can throw is this maximum. So it will be happening at theta equals to 90 degree because h max has a formula v square sine square theta upon 2g. So maximum height is attained by the ball is maximum when theta turns out to be 90 degree, that is when ball is thrown vertically upwards. So this ball was thrown vertically upwards and it got height h, so initial velocity is v. So what's the greatest distance by which he can throw the ball? So greatest distance would happen if he throws at an angle 45 degree, and in that case range is v square sine 2 theta upon g. The theta equals to 45 degree, so sine 2 theta equals 1, so v square upon g. And in this case, if we apply the formula v square equals u square plus 2gh, then v square is 0, u square is v square plus 2 into a into s. So 0 square equals v square minus 2gh. So v square is 2gh, and if you put this same v, because man's ability is same, he can throw with the same velocity v, that becomes 2h. Answer D. Question number 14 says a stone is thrown at an angle theta to the horizontal, reaches a maximum height h, then the time of flight of the stone would be. It is the same question as question number 11 and question number 12, where the ratio of h over t square comes out to be g over 8. So we can write time squared in terms of all of these. So 8h upon g, and t comes out to be 2 root 2 under root of h by g. That is option number B. Question number 15 says a bus starts from rest with an acceleration of 1 meter per second square. A man who is 48 meter behind the bus starts with a uniform velocity of 10 meter per second. The minimum time after which man will catch the bus. So man is here, he is 48 meters behind the bus, and the bus starts at t equals to 0 with acceleration of 1 meter per second square. Man is moving with a constant velocity of 10 meter per second. So let's assume they meet at some distance x from here, that is somewhere over here. Now this x can be written as 10 into time t, because that is what man travels with. But the bus travels only a distance of x minus 48. So for the bus we can write x minus 48 equals to ut plus half at square, where u is 0, so u goes to 0, half into a, which is 1, into t squared. It also travels for same time t because they are meeting after time t. So let's put the value of x over here. 10t minus 48 equals t square over 2. T square equals 20t minus 96. T square minus 20t plus 96 equals to 0. And we know 12 into 8 is 96. So t minus 8, t minus 12 equals 0. So time comes out to be 8 seconds as well as 12 seconds. Which one to choose? 8 seconds, because this is the minimum possible time where they'll meet. They'll meet after some more time also, that is 12 seconds, but that's not asked in the question. So answer is B. Question number 16 says a boat takes 2 hours to travel 8 km and back in still water. So let's say this is the river, and boat first travels in still water and it travels 8 kilometers there and back with a speed of u equals 8 plus 8, and it returns back in 2 hours. So that is 8 kilometers per hour. Now river also started moving with velocity of 4 meters per second. Now what time it will take for him to go 8 kilometers and come back? So while going upstream, his velocity would be 8 minus 4, that is 4 meters per second. And while downstream, his velocity would be 8 plus 4, that is 12 meters per second. And he has to travel the same distance, 8 kilometers and 8 kilometers. So this would take time t1, this would take time t2. You have to find t1 plus t2. So t1 plus t2 is nothing but 8 by 4 plus 8 over 12, which is 2 plus 2 over 3, that is 2 hours plus 40 minutes, that is a total of 160 minutes. Question number 17 says, a boat which has a speed of 5 km per hour in still water crosses a river of width 1 km along the shortest possible path in 15 minutes. So velocity of the river is, so shortest possible path with respect to ground is going like this, so it will make you go in this direction and you'll go like this and you'll reach here. So this is velocity of boat with respect to river. In river it will be moving like this, but as river is also moving in this direction, so with respect to ground the boat will be moving in this direction. So this is given as 5, this is given as 4, so you already know this would be 3 and this angle would be 37 degrees. Question number 18 says, a rain is falling vertically downwards with a speed of 4 km per hour. Girl moves on a straight road with 3 km per hour. The apparent velocity of rain with respect to the girl is, so let's say rain was moving vertically downwards with respect to the ground, so this is velocity of rain with respect to ground. Now rain is moving like this when the lady starts moving, so this is velocity of rain with respect to the lady. Now you can say velocity of rain with respect to the ground is equal to velocity of lady with respect to the ground plus velocity of rain with respect to the lady. So this comes out as this. So velocity of lady with respect to ground was like this. Now this is equal to 3, this is equal to 4, so obviously this becomes 5. So velocity of rain with respect to lady will be, you can write it in vector notations as well, that velocity of rain with respect to lady is equals to velocity of rain with respect to ground minus velocity of lady with respect to ground. Velocity of rain with respect to ground is 4j cap and velocity of lady with respect to ground is 3I cap. So what is the magnitude? It's 5 km per hour. Question number 19 says, a 150 meter long train is moving north at a speed of 10 meters per second. A parrot flying towards south with a speed of 5 meters per second crosses the train. The time taken by the parrot to cross the entire train, so train is 150 meters long and it's moving in this direction with 10 meters per second. Parrot is moving in this direction with 5 meters per second and the distance the parrot has to travel is 150 meters. So the speed of parrot with respect to train comes out to be 15 meters per second. So if you assume the train was at rest, the parrot is moving with 15 meters per second with respect to train, so it would take time 150 over 15, that is 10 seconds for him to cross the train. Alright, so in question number 20 it gives us two circular motions A and B. VA equals 2 meters per second, which is doing a circle with radius 1 meter, and VB is 4 meters per second, which is doing a circle of 2 meter radius, and we have to find acceleration of A with respect to B. So in vector format you can write it as acceleration of A with respect to ground minus acceleration of B with respect to ground. But if you just need to find the magnitude of it, you know that both of these accelerations are centripetal acceleration, which is nothing but V square by R, and they are both in opposite direction. So if the magnitude is just asked, acceleration of A with respect to B, that is magnitude of acceleration of A with respect to ground plus acceleration of B with respect to ground, and which is equal to 2 square over 1 plus 4 square over 2, that is 4 plus 8 equals 12 meters per second square. Question number 21 gives us 3 different vessels of same base area and equal volumes of same liquid are poured into these 3 vessels. So they are equal volumes and same density, that means same mass of liquid are present in these 3. Now what is the force on the base of those vessels? So as you can see, here the force will be mg, here also the force will be mg, and here the force will also be mg. But we are leaving out one of the force, that is normal reaction from the vessel, which will be in this direction. So it will have n1 in this direction, n2 in this direction, which is in upward direction. So here the net force is mg minus n2. But as normal reaction is horizontal in this case, it will still remain as mg. But in this case normal reaction is downwards, so n1 will still be here, but N2 is downwards, which is increasing the force by mg plus N2. So which one has more force at their bottom? Vessel C. Now in question number 22, we have identical vessels but with different densities, rho A, which is less than rho B, which is less than rho C. But it is also given that they have equal masses, M and N and M. That means they have different volumes. Now force at the base will be, so here force is mg, mg and mg. But as there is no normal reaction from the side of the container, it will still be mg, mg and mg. So equal forces at the bases in all the three cases. Hence option number D. Question number 23 gives you a piece of wood is floating in water kept in a bottle. Now you are compressing some more air into the bottle and you are asking now how much part will be inside the water. So this H which is inside the water, it's increasing or decreasing if we put more air inside, right? So let's say there was initially P0 pressure. So here the pressure would be P0 plus rho GH. Now if we increase the pressure from here P0 to P0 plus P air, here also pressure will get increased by P0 plus P air and plus rho GH. So the delta pressure between these 2 points is exactly the same. It's not changing. And as it is not changing, the amount of wood which is inside the water will also not change. Question number 24 says, in a hydraulic lift used at a service station, the radius of the large and small piston are in ratio 20:1. What weight should be placed here so that it can lift a weight of 1500 kg over here? So this is a pretty simple question on Pascal's law, which says that if you increase the pressure P1 by that side, it would also be increased by same on the other side, that is P1 equals to P2, and pressure here is increased by mg is the force and area is pi r square, and pressure here increased by 1500 kg into g, that is the force applied, divided by area, pi into 20 r whole squared. So here g gets cancelled, pi gets cancelled, r square gets cancelled, and m comes out to be simply 1500 over 400, that is 3.75 kgs. So just a weight of 3.75 kg is enough to lift a weight of 1500 kgs. Question number 25 says, a body floating in a liquid, the upthrust on the body is equal to the weight of liquid displaced, 0 less than and t. Okay, so this is a pretty simple straightforward question. It's simply A, that says that upthrust in a liquid is equal to weight of the liquid displaced. That is simply Archimedes' principle. Question number 26 gives you a hollow sphere of volume V is floating on the surface with half immersed in it. What should be the minimum volume you should put inside so that sphere sinks? Alright, so initial condition is on this body there are two forces, buoyant force in upward direction, gravitational force in downward direction. Both of them are equal. Buoyant force is equal to mass of water displaced, that is density of water into volume of water displaced, which is V by 2 into G, and which is also equal to gravitational force, which is nothing but mg, right? So we can say mg equals rho vg by 2. In the second case, you have put some water inside V dash volume, let's say, and it's sinking now. So write down the situation for here, FB and FG, they are both equal in this case also. So FB in this case is rho into full volume it's displacing now into G, and Fg is equal to mg, that is mass of the shell, plus some water you have put into it, so V dash into rho into G. Now just replace mg as this, so you get rho Vg equals rho Vg by 2 plus rho V dash G, hence simply V dash equals V by 2. So how much volume of water you had to put? Half the volume. Question number 27 gives us a scenario when a cube of ice is floating between water and oil, and you have to find how much length it is inside the water to how much length it is inside the oil. So you have to find basically x1 over x2. So let's say total length is x, so you have to find x1 over x2. That means x1 can be written as x minus x2 over x2. So let's try to make the FBD of it. On this body there are three forces. First is buoyant force by oil, then there is buoyant force by water, and finally mg is acting downwards. So you can say mg equals buoyant force by oil plus buoyant force by water. Now let's say area of this cube was A, so area into x, which is volume of the cube, into density of the cube, into G is basically mg. Buoyant force of oil is amount of oil displaced. Amount of oil displaced is volume A into x2 into density of oil, that is mass of oil displaced, into G will give you weight of oil displaced, plus weight of water displaced, that is A into x1 into density of water into G. Let's cancel G, let's cancel A, and now let's put all the values. So x into 0.9 equals x2 into 0.8 plus x1 into 1. So this becomes 0.9x equals 0.8x2, and x1 can be written as x minus x2, which gives us 0.2x2 equals 0.1x. That is, x2 will be equal to x over 2. So x1 will also come out as x over 2. So what's the ratio? Ratio will be 1:1, which is inside the oil and inside the water. Now in question number 28, water is flowing through long horizontal tube. PA and PB are pressure at two different points, and you have to find the relationship between PA and PB. So let's say this is the pressure PA, this is the pressure PB. Here the velocity is VA, here the velocity is VB. Now let's try to write down Bernoulli's principle, which says PA plus half rho VA squared plus rho G HA must be equal to PB plus half rho VB squared plus rho G HB. And here we can say rho G HA, rho G HB will get cancelled because HA and HB are same. So we get PA plus half rho VA squared must be equal to PB plus half rho VB squared. So PA is only equal to PB when VA equals VB. That is, velocity here must be equal to velocity here. And from equation of continuity A1 V1 equals A2 V2, we can directly say that when areas are equal, then only velocities will be equal. Hence option number D. PA equals PB only when cross-sectional area of A and B are equal. In question number 29, a horizontal pipeline carries water in a streamline flow at a point along a pipe where cross-sectional area is 10 centimeters square. The velocity of water is 1 meter per second. So here water is moving with 1 meter per second. At 5 centimeters square, velocity of water will be A1 V1 equals A2 V2. So A1 is 10, V1 is 1, A2 is 5. Hence V2 is simply 2 meter per second. So here velocity is 2 meter per second. If at this point the pressure is 2000 Pascal, you have to find what's the pressure here. So let's say this is PA. Now let's apply Bernoulli's theorem that says PA plus half rho VA square plus rho G HA equals PB plus half rho VB square plus rho G HB. Again they are at same height, so rho G HA rho G HB gets cancelled. So PA, that is 2000 plus half rho VA squared, rho is 1000 because it's water they are carrying, into VA squared, that is 1 squared, must be equal to PB, which is what we have to find, plus half rho into VB squared, and VB we have found to be 2, so 2 into 2. So this is 2000 plus 500 equals PB plus 2000. Hence PB is simply 500 Pascals. So we have reached the final question. This question says water from a top at the end of the horizontal pipe. So let's say this is horizontal pipe. Emerges at an initial speed of 1 meter per second. The cross-sectional area of tap is 10 to the power minus 4 meters square. Assume that the pressure is constant throughout the stream. That is, pressure here PA is equal to PB. Then you have to find 1.5 meter below what is the cross-sectional area here. Hence the first thing to apply is equation of continuity, which says A1 V1 must be equal to A2 V2. So here area is 10 to the power minus 4, velocity is 1 meter per second, here area is V and velocity is, let's say, V. So we can write velocity here, V is nothing but 10 to the power minus 4 over area here. Now let's try to apply Bernoulli's theorem, which says PA plus half rho VA squared plus rho G HA equals PB plus half rho VB squared plus rho G HB. Now PA and PB are equal, so they get cancelled. and if they get cancelled, row get cancelled. So we have a simple thing, VA squared, so VA is 1, so 1 squared by 2 plus G into HA, G is 10 and H is 0.15 equal to VB square over 2, and VB is 10 to the power minus 4 over area, so this whole squared over 2 plus rho G HB, HB is 0, so this is 0. This comes out to be 0.5, this is 1.5, so this is 2, and 2 into 2 is 4, that is 10 to the power minus 5 by area whole squared. So we finally get 10 to the power minus 4 by area is 2, and area comes out to be half of 10 to the power minus 4. And that is also equal to 5 into 10 to the power minus 5 meters square. Hence option number C. So that's it guys. That was the final question of the test.